Lesson number 82 is about evaluating functions and domain and range. And now, to begin, we're going to evaluate some functions. And our first function says, if f of x is equal to x squared plus x minus 10, we have to find f of 5. Now, remember, when we see function notation like this, it means we need to solve for our value of x that's given to us in the problem. So our value of x that we're going to solve for is 5. So the way we can rewrite is to say f of 5 is going to be equal to, and wherever we see x, we're now going to substitute in 5. So we're going to get 5 squared plus 5 minus 10. And then we can go ahead and solve. I'm going to make the pen a little bit bigger. So we've got f of 5 is going to be equal to 5 squared, that's 25, plus 5 minus 10. 25 plus 5, that's 30, and 30 minus 10 is going to give us our answer. So we have f of 5 is equal to 30 minus 10, that must be 20. So f of 5 is equal to 20, and this is how we'll report our answer. We're saying the value of the function when x equals 5 is 20. Alright, let's go ahead and look at another one. Here we have, if f of x is equal to x squared plus 1, find f of x plus 2. Now this one's a little bit different because we need to substitute this whole x plus 2 in wherever we see x. But we do the problem the same way we did before. So we're going to say f of x plus 2 is going to be equal to, remember to use parentheses every time you substitute a value in, x plus 2, because that's x squared, plus 1. And now we can solve. We know x plus 2 squared, that means x plus 2 times x plus 2. Whole thing is plus 1, and we have our function notation to begin with. F of x plus 2 is equal to all this. So let's solve. F of x plus 2 is going to be equal to, well, using our FOIL method, the first x times x, that's x squared. The outer numbers, x times 2, that's going to be plus 2x. The inner numbers, it's going to be plus 2 more x's. Plus the last numbers, 2 times 2, that's 4. And then plus 1. Now we can simplify to get our final answer. So we're going to get f of x plus 2 is equal to x squared. And then we have 2x plus 2x, that must be 4x's. Plus 4 plus 1, it's going to give us 5. And we've got our final answer. So we can go ahead and report it like this. The value of the function when x is equal to x plus 2 is x squared plus 4x plus 5. And we've got our final answer. Let's move on to the next question. This one's a little bit different. It says, if f of x is equal to 2x, find the domain and range of the function f. So domain. Domain is a word that just means all possible x values. And range must be the opposite. Range is all possible y values. And now when we look at these, we're looking at our specific function. So the first thing we need to do is graph it. We have f of x is equal to 2x. Well, there's no y-intercept given, the b value, the constant, so that must be 0. And then our slope is 2, so that means up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. Now we can go ahead and take out a straight edge and graph that line. And it should look something like this. We're going to take our line and make our arrowheads just so we can see it. Now, what we can tell about this function is if we look for all the x values, well, we can see all the x values that are possible for this function, if we look at the graph, we can see this graph continues forever and ever and ever and ever as a line, and forever and ever and ever as a line to the right and to the left. So our domain D is going to equal all real numbers. In our range, all the y values that are possible in this function, well, we can see the same thing happens with our y values. They just keep going up and up and up and up, and down and down and down and down. So our range R is also equal to all real numbers. Now let's look at another one, because you might be thinking, well, won't the domain always be all real numbers and the range always be all real numbers if we're working with lines? Let's look at a few more examples to help answer that question. In the graph, if the graph of a function f is shown, determine the domain and range of f. So this is not a linear equation anymore. This is two segments. Here we've got one segment that starts just after this line because it's an open circle, starts right there, goes down to our origin, and then pops back up. And it pops back up, and this point is included. So that's important, because if we want to solve this, we need to figure out our domain first, D. And remember, domain is the x values that are possible. So what we can see for the domain, it starts at -2 on the x, and then it goes all the way over here to +3 on the x. So the domain, well, -2 is where this graph starts, so we're looking at everything just on the x-axis for this function. -2 is going to be less than our x values, which is going to be less than or equal to 3. And we just use the less than symbol because we have the open circle, and we use the less than or greater than symbol because we have the closed circle on the 3. So that's our domain. That's everything that's possible on our x-axis. Now the range. For this function, the range R, well, we start at 0, and you can see it goes down, it hits 0. So 0 is going to be less than or equal to y. And then it goes all the way up to a maximum of 1, 2, 3, and 4. Goes to a maximum of 4, and it's a closed circle on 4, so we're going to get less than or equal to 4 as our range. This is an example of a function that doesn't have a domain or range of all real numbers. It's restricted because the graph only goes for a limited time on the x-axis and the y-axis. Let's look at another example. Our next problem says to find the domain of the function f of x is equal to the square root of 5 minus x. Now this problem we don't need to graph to find out what our answer is, but what we do need to do is find the domain, so all possible x values that are true, by looking at our function and saying what we can have. Now, if we look at this 5 minus x, we know we can have no negative numbers with a square root. So those are not real number answers anymore, because you can't take the square root of a negative number. So what we could do is we could look at possible values we could have. Well, we could have 5 minus 4. We could take the square root of that, because the square root of 5 minus 4 is the square root of 1, which is equal to 1. We could also have the square root of 5 minus 5, because the square root of 0, we could figure that out. The square root of 0, that must be 0. But if we had the square root of 5 minus 6, suddenly we've got the square root of -1, and there's no number that can be multiplied by itself to get us to -1. So what we see helps us to find our answer, because this is not possible. But this is, and this is. And any number smaller than 4 would also be, including negative numbers. So the way we could write our answer would be to say x has to be less than or equal to, and if we look back, it can't be 6, but it can be 5. It can be 4. It could be 3, 2, 1, and so on, smaller and smaller. So x must be less than or equal to 5. And that's how we would report our answer for the domain of this function. Our lesson practice will be on page 340. Make sure you got your notes complete, and I'll see you during our next class.